It's my pleasure to introduce Dr. Renske Lok. She's the Vice President of the Society of Light, Rhythm, and Circadian Health. She earned her PhD at the University of Groningen, and she is now a senior postdoc at the Department of Psychology and Behavioral Science at Stanford. And she specializes in the non-image forming effect of light on circadian rhythm and sleep-wake pattern. And today she'll talk about how daytime light exposure shapes nighttime sleep quality. So, Renske, I give you the floor.
Thank you. Good morning, everybody. Very happy to be here. Thank you for the organizers for organizing this super interesting webinar, and I'm very happy to be presenting here. I'll be talking a little bit about some of the work that we did and give a small overview of the things that have been done in the field with respect to light exposure and how it can actually influence our sleep at night, which is usually a topic that people don't really think about. So the title of my talk is How Daytime Night Exposure Shapes Nighttime Sleep Quality. And something that I kind of want to bring to the attention is that I personally think that the emergence of electrical lighting has changed our relationship with lighting as it extends our ability to stay up beyond dusk. And the easiest way to think about this is that before there was any electrical lighting or any other way of making light after sunset, it was really as soon as the sun set, we would go to bed, and as soon as the sun rose, we would come up. So we would live as long as the sun is out, and we would go to bed as soon as the sun set. And of course, this relationship kind of changed first with the emergence of fire, then with the emergence of gas. And then as we progressed, we got incandescent light, fluorescent light, and now we're kind of in the era of LED lighting. And the fact that we have access to all these light tools makes it that we don't just have to go to bed as soon as the sun sets and actually have to wake up as soon as the sun rises. And, you know, saying it like this, it almost sounds a bit crazy. So it's something that we're really, really not used to anymore. But I think this ability to expose ourselves to artificial light has changed our relationship with lighting and our rest activity patterns and sleep patterns. And it's kind of funny because if you look at the original plaque of the Edison electrical light bulb, it says, do not attempt to light with match, simply turn the key on the wall by the door. And then in very small in the bottom, it says the use of electricity for light is in no way harmful to health, nor does it affect the soundness of our sleep. And this is something that I kind of want to attest. I think it was true for that time, that was our current line of thinking. But I think that has changed a lot. And we know that this is not actually true, and that light can definitely influence the soundness of sleep. And just like Virginie explained, I will reiterate very briefly, is that the fact that you can see me and that I can really not see you, but that I can see my presentation, is because light really enables us to perceive the world around us. So this is a depiction of the eye. Let me make this pointer. So this is a depiction of the eye where light enters the pupil and it hits this back layer of the eye, which is called the retina. And the retina is packed with cells that translate light information to the brain. And this is the reason why we can see, both when there's high intensity lighting and also in dusk and dawn. So light enables us to perceive the world around us. But light does so much more. So light has a lot of non-image forming effects of light, which means effects of light that have nothing to do with vision. And just like Virginie explained, it means that light can influence when we go to sleep, how we go to sleep, how alert we feel, and how well we perform cognitively, for example. And light has these functions through various pathways in the brain. And the most well-known pathway through the brain is the projection from all these cells in the eye to the SCN, the suprachiasmatic nucleus, the location of the central pacemaker. And this is a pathway that has been studied for, I think, at least 50 years, in which we know that light can influence the timing of the suprachiasmatic nucleus. But we start to know more and more that there are effects of light that go beyond the suprachiasmatic nucleus. So there are projections of all these cells in the eye to various nuclei in the brain, independent of the SCN. And these nuclei have been associated with lots of non-image forming functions, including sleep-wake regulation, which is located or organized in the ventrolateral preoptic nucleus. There are regions in the brain associated with mood, so light can have direct effects on how you feel, and alertness and cognition, which is mostly located in the lateral hypothalamus. And I think when I talk about light and the effects of light, I cannot really talk about it without talking about at least light intensity. So for the rest of the presentation, I will kind of reference various light intensities, and all that I really want you to remember is if I talk about 5 to 10 lux, I talk about very, very dim lighting, just enough to see, more or less an equivalent to being close to a candle. If I talk about 150 to 500 lux, that's usually office lighting or home living room lighting. And if I talk about lots of sunlight, so above 10,000 lux, I'm talking about outdoor light exposure and some light therapy lamps. And one of the most common questions I actually get is, do I also get 10,000 lux if I go outdoors and it's a cloudy day? And the short answer is yes. Even on cloudy days, you get above 10,000 lux of light if you go outdoors. So you can imagine the range is quite large. Candlelight, very dim. Home office lighting is usually a little bit in between, and outdoor light exposure is super intense and gives the strongest signals to our brain with respect to time of day and what to do, really. So today I'm going to talk a little bit about the light effects on physiology and sleep. And I'm going to do so because I personally think that light stands as one of the most powerful non-pharmacological tools available to really promote and enhance human health and well-being, and if we use it correctly. And it has really far-reaching effects on both our psychology, which I'm not going to be talking about today, but also our physiology. So the question then is, can daytime light exposure improve or change nighttime sleep? And I really want to preface that by saying that a lot of popular articles like to highlight the negative roles of light. And I think if you go on Google and Google light and health or light and sleep, these are the kinds of articles that you'll see, how artificial light at night really influences our quality of sleep, how it has effects on, for example, Alzheimer's progression or the development of Alzheimer's, how it's bad for health overall. And how it influences obesity, for example, and heart health. And I think, yeah, these articles kind of like to highlight the negative effects of light, but I think something that we kind of forget, and this is coming back to the beginning, is that light really influences our behavior. So being exposed to a lot of light at night usually changes our behavior. And this is kind of a famous tweet that Netflix put out in 2017 saying, "Sleep is my greatest enemy." And something that Netflix acknowledged is that its biggest competitors is not Amazon or Hulu or cable, but it's really sleep. And if you think about it, all that Netflix wants to do is make you sit and watch the next episode in the evening. And of course, when you're doing this, you're not sitting in the dark, right? So you're being exposed to artificial lighting. So the big question then kind of becomes, is it really the light itself that has all these negative influences on human health? Or is it what light enables us to do? In other words, stay up and watch Netflix. And these are some of the questions that I will not completely go into today because a lot of this still remains to be done. But it's kind of to be a little bit provocative and make you think about these kind of things. So if we study these kinds of questions, light and human behavior and influences on health, we kind of have to turn to big population studies. So we like to assess sleep patterns in large-scale population studies. And we do so by using a wrist-worn device. It's called an ActiWatch, and you just place it around your wrist. And with that, we can record rest activity patterns in humans. And when we plot that out, this is kind of what it looks like. So this is the rest activity pattern of a participant on one day of the week, on Monday and Tuesday. And you'll see intervals where there's very little activity, very few black bars, meaning intervals for sleep. And there are intervals where people are very active. So lots of black bars means lots of activity. So these are periods where people are really awake. And you can measure this for every day of the week, and you can create something that is called an actogram, which very clearly outlines when somebody is asleep, very few black bars, very few activity, and when somebody is awake, lots of activity. And this in the lab or in research, we really do this with a research grade device. But it's no different than what the consumer wearables really do. So if anybody in the audience has an ActiWatch or a Fitbit or a Garmin, this is really what your watch does to tell you something about your timing of sleep and also about the quality of sleep. And we can use this data to inform us about the influence of these rest activity patterns on health. So if we look at the timing of sleep, for example, we can see how this affects our health. And if there is a relationship between the timing of sleep when we go to bed and how healthy we really are. And to do so, we looked into the data of the UK Biobank. And I don't know if anybody in the audience knows, but this is a really, really big biobank with millions of activity records. Each activity record spans 1 week of minute by minute data, and that means for one participant, you have about 10,000 data points. And you have over 1 million participants. So in the end, we had to analyze billions of data points to extract the sleep timing of about 74,000 individuals. And then we used ICD-10 codes, basically hospital codes. So you go to the hospital and you get diagnosed with a certain disorder to assess physical and mental health outcomes. And really with the question, does sleep timing influence your mental and physical health? And the short answer is it really does. So what we noticed in individuals that go to bed early or early-ish, I mean, these are people in the UK and their bedtimes are quite late, I would say, to begin with. So early people went to bed around 11:30. Late people went to bed around 2 a.m. And what we noticed is that there was a significant influence on their mental and physical health. And all you really need to know is if something is red, it means significantly worse. And if something is gray, it means non-significantly worse or better. And blue means significantly better. In other words, when they went to bed early, they had a little bit less chance of having depression. But when they went to bed late, there were much higher rates of mental, behavioral, and neurodevelopmental disorders, depression, and generalized anxiety disorder. In other words, those that go to bed late have a higher chance of having mental health disorders. And it's not just mental health disorders, it's actually also physical health disorders. So all the disorders that we investigated were higher in those that went to bed late. So metabolic disorders, diabetes, obesity, hypertension, circulatory disorders, digestive disorders, respiratory disorders, and even all-cause cancer. There were significantly higher rates of all these diseases in people that went to bed late versus people that went to bed early, meaning that sleep time at least was associated with both mental and physical health. Now, of course, an association is an association, so we were curious, can we determine this a little bit better? And something you can do is called a survival curve analysis. And it means that at time point 0, you grab all the people that never have had this disease before. So in this case, these were the levels of depression. So we investigated all the people that at time point 0 never have had depression before. And we looked if in the 8 years, so we looked up to 8 years later, if they ever developed depression. And if these rates were different for those that went to bed early in yellow or those that went to bed late in purple. And the rates were very, very different. So if we look at those who went to bed early, you know, at the end of the 8-year follow-up mark, there were about 97.5% of the people that still did not develop depression. Whereas in those that went to bed late, there were many more that actually developed depression. And of course, you can say the percentages here are very small, you know, it's a 1 to 2% change. But if you remember that this is in about 70 4,000 people, it means if you have a 1% difference, that means 700 people more develop depression that went to bed late versus that went to bed early. And also this was something that was mimicked in the other disorders that we investigated. So also in mental, behavioral, and neurodevelopmental disorders, depression, as I just showed you, generalized anxiety disorder, and some of the physical disorders that we included, including diabetes, obesity, respiratory disorder, hypertension, and circulatory disorder, we see the same pattern, such that people that go to bed late develop more of these mental and physical health disorders than people that go to bed early. In other words, timing of sleep has a significant influence on your mental and physiological health. And again, if this is due to the light, because the hypothesis is when you go to bed late, you're not sitting in the dark. We don't know that yet because this data set didn't lend itself to an analysis of light. So this is something that still remains to be determined. So of course, the title of my talk really is about sleep quality and lighting. So what is it about light that can be positive for human health and positive for sleep? Because if there's one thing that we do know is that good sleep is essential for mental and physical health. So then the question kind of becomes, can light influence how we sleep at night? And can light have these positive effects as well? So we did this quite interesting study in which we investigated the daytime light exposure effects on nighttime sleep quality in young, healthy adults. And what we really did is we included a bunch of young, healthy people, and we asked them to go outside and go for a walk for about 3 hours at a specific time in the day. And we asked them to do this once under normal light conditions, so high intensity lighting, being exposed to this 10,000 lux, and once under attenuated light, so dim light conditions. And if I talk about dim light conditions, what we really did is we asked them to do the exact same walk, but wearing really big ski goggles that reduce the light intensity up to 10 lux, so candlelight light intensity. And then we went into their houses and we put a bunch of electrodes on their face and we told them to go to sleep whenever they wanted and we would record their sleep. So we went to their house and attached electrodes to their skull and this is how they actually went to bed. And in the morning we asked them, how do you actually feel you slept? So we had both, let's say, an objective output measure of sleep, so electrodes, PSG, and we had a subjective measure of how they felt they slept. And we were very interested in how these two would correlate and if light could positively influence the sleep experience. And interestingly, if we look at these results, and in gray are depicted the ones in dim light, so with the big ski goggles, and in yellow are the ones under high intensity lighting, we saw that there were really no effects on self-chosen timing of sleep or sleep duration. In other words, independent of how much light they were exposed to, they actually went to bed at the same time and they slept equally long. And by the time that they went to bed, so that's the bottom graph, they actually felt equally sleepy. So we're always interested in how alert or how sleepy they felt. However, if we look at the outputs of the PSG, so the electrodes attached to the skull, we see that individuals, when they were exposed to the high intensity lighting, so without the ski goggles, they had a lot more deep sleep compared to when they were exposed to the dim lighting. So they slept a lot deeper, they were awake a lot less, and they had less light sleep. So their sleep was more intense and more consolidated, really. And interestingly, what we also saw is the next morning, they felt a lot better when they woke up. So both they slept deeper and the next morning, if they had been exposed to high intensity lighting, they felt a lot more alert. So this is a sign that the amount of light exposure, so if you're exposed to a lot of light during the day, you'll sleep better. And the next day, you'll actually wake up feeling a lot more refreshed. So this is a really positive effect of light. And this was very exciting to us. But of course, we conducted this in healthy young individuals. And if there's one thing about healthy young individuals, they do not have any sleep problems. They always sleep good. So it's really amazing to find an improvement in sleep because it's kind of like cleaning a window that is already super clean. You cannot get that much improvement. So then we kind of asked whether there maybe would be a therapeutic applicability of light. So in other words, can we also improve sleep in those that have sleep problems by exposing them to more light? So then you kind of have to find a group that has sleep problems. And as I said, young individuals have perfect sleep. So they go to bed, they have a little bit of light sleep, they wake up a couple of times, and they have lots of deep sleep. But for those in the audience that maybe are a little bit older, know that your sleep changes with age. And as we grow older, something that becomes very apparent is that the periods of wakefulness really increase. So as opposed to really, having lots of light and deep sleep with a little bit of wakefulness when we're young, as we get older, we get many more bouts of wakefulness. Less deep sleep and a little bit less light sleep. So these are really people that we would qualify as having a little bit of sleep problems, because they will say it's very, very bothersome. And this is something that, again, we can quantify quite nicely with these ActiWatches, these wrist-worn devices. And if you plot out their rest activity data, this is more or less what it would look like. So if you have low sleep-wake fragmentation, so kind of what the young people have, you go to bed, you sleep, and during the day you're awake. This is kind of what it would look like. So you have lots of activity during the day, and by the time you go to bed, you have very little activity because you're asleep. However, as we age and we get more of the sleep-wake fragmentation, you'll see that the pattern becomes a bit more fragmented. As I indicated, while we are asleep, we get bouts of wakefulness. So we sleep a little, we're awake a little, we sleep some more, we're awake some more, and we sleep some more. And usually what this also means, and that's why I call it sleep-wake fragmentation, is that during the day, these are also the people that like to sleep or take some naps during the day because they don't sleep so much at night. So during the day, they're active for a little bit, then they snooze off a little bit, then they're active, they snooze. And, one of the most common scenarios is somebody sitting in front of the TV and like falling asleep for a little bit, and then being awake for a little bit, and then falling asleep again. And this is really a pattern of, we would qualify high sleep-wake fragmentation. And as I mentioned, it's very bothersome to the people themselves. I mean, people don't want to be asleep during the day. And it's also associated with lots of mental and physical health disorders and cognitive decline. So our idea is that if we can restore this sleep-wake fragmentation, maybe by light exposure, maybe we can also improve these mental and physical illnesses and restore the cognitive decline that usually goes with the sleep-wake fragmentation. And we have some exciting preliminary data showing that this might be the case. So it's preliminary, so not conclusatory. This is very much ongoing research, but I wanted to share with you today that we have some insights that light might help with sleep-wake fragmentation. So this is in a sample of about, I noted it here actually, we did this in a sample of 877 men that were a median age of 80 years. So they were quite old and they had quite some sleep-wake fragmentation as well. And we looked at their daytime light exposure profiles and how much sleep-wake fragmentation they had. And we noticed that in those that had very little sleep-wake fragmentation, so nice activity patterns during the day, very little activity at night, they spend a lot of time outdoors. So they were outdoors for about 2 hours a day. So they got a lot of light exposure, and this was associated with less sleep-wake fragmentation, better mental health, better physical health, and better cognitive health. On the other hand, those with lots of sleep-wake fragmentation, so lots of sleep during the day and lots of activity at night, they spend very, very little time outdoors, maybe, 0 to 30 minutes only, suggesting that the amount of outdoor light exposure is significantly associated, at least with the degree of sleep-wake fragmentation. And now the next step, of course, is to test this. So if we intervene and if we expose this group of people with lots of sleep-wake fragmentation to high intensity lighting at specific times of day, will they turn to better sleepers? And this is something that we're very interested in doing over the next couple of years. So today, my talk in how daytime light exposure shapes nighttime sleep quality. I hope I showed you that sleep timing is linked to both mental and physical health, with later sleep schedules associated with poorer mental and physical health outcomes. Exposure to daytime daylight exposure can improve sleep quality and reduce next day sleepiness, even in people who are already very good sleepers. And daytime light exposure is linked to improved sleep-wake consolidation in older adults who often experience a greater degree of sleep-wake fragmentation and various mental and physical health disorders. So with that, I would really like to thank the organizing committee again for providing me the opportunity to present my work here today, and my supervisors, my current supervisor, Jamie Seitzer at Stanford University, my previous supervisors at the University of Groningen, Domien Beersma and Roelof Hut, and from Chrono at Work, Marijke Gordijn. Thank you so much for listening.